Hello, let's continue our study, weight and mass, or mass and weight. So we have here an example. Uh, Weight is a force of gravity by Newton's second law. Weight, or W, is equal to mass times G. So as we have discussed in the first video, that weight is not the property of matter, but rather it is what it says. Okay. Weight is not the property of matter, but it is dependent on the gravitational attraction. Right? The stronger the force of a gravity, the more object will weigh. So this is what he is saying here, that weight is a force of gravity, and by the second law of Newton, your W, or weight, is equal to mass times g, which is gravitational acceleration. Okay, so that's the problem here. So how does weight changes with elevation? Okay, here's the solution. Since mass remains constant, so mass remains constant, right? Mass remains constant. Weight is not, because it depends on the mass. If your mass is constant and your g is not constant, then your weight will change, right? What I'm saying is, if your W is equal to mass, okay, times G, if mass doesn't change, this is constant, it doesn't change, so this is constant, okay, your G vary. Hey sir, that is constant. Yes, that is constant if you are on Earth. What if you go to moon? This G is not constant anymore. This is dependent where you are. Of course, it is constant because we are here on Earth. This is Earth gravitational pull or attraction. But if you go to another planet or another uh, in solar other solar in our solar system, then, for example, in the moon, you have another constant G there, right? So weight varies because it depends on G. Okay, so let's continue. The of W, which with elevation is due to the change of acceleration of gravity. So even here on Earth, G will vary depending on the elevation. Okay, from 9.77 meter per second square on the highest mountain to 9.83 meter per second square in the deepest ocean. We will use the standard 9.81, right? We are using this for 32.2 feet per second square. The 981 is meter per second square, unless otherwise stated. So, not just G, G does not only vary it when you go to the moon, but also it varies depending on the elevation. And this is what the solution says, right? Okay, let's move on to the next example. So in example 1.4 here, express the energy unit or joule in terms of SI base unit like mass, length, and time. So here is our solution. Recall that energy or work is force times distance, right? What he's saying, that energy is equal to force F, right, times distance. We call it distance. We don't put that on it because that will make us confuse. So energy is just simply equal to F times D. We know that, okay? Hence, in example 1.2, the energy unit in joule is equal to N times M, okay? And we know that we know that Newton is 1 kilogram mass per second square. And that is actually mass times acceleration times M. Times M is what? Distance, right? This is a distance. It's like mad, right? M times accelerations times D, mad, and this is the unit. 1 kilogram meter square per second square. And that is actually joule. Why it happened? So analyze the unit here. 1 kilogram, you have kilogram there, right? So M times M here, M square. And then just write down the second square. And that is actually equal to joule, right? So maybe in the board exam, they will ask you for this. What is the equivalent unit of joule? And this is one of the, what you call that? In the selection, it is there. So you must understand that, okay? Or maybe in the selection, it is also there. So you have to choose, right? Let's continue. And then in the English system, both in the English system, both pound force and pound mass are base units. Okay, as indicated in table 1-1, the primary energy unit is foot pound. In example 1.2, right? Example 1.2 we have here, right? And this is the unit that he is saying. 1 point, this is the 1.2. Okay, 1 foot-pound force is equal to 32.2 pound mass feet square per second square, and that is actually one slug foot square per second square, analogous to the SI relation found above. Okay, so you need to understand the unit system. Okay, like in here in table dash, sorry, table 1 dash 1. Okay, we have the quantity, we have the symbol, we have the SI units, we have the English units, and we have the conversion factor. So in length, we have meter, feet. In mass, we have kilogram, pound, force. Time, we have second, second. In area, we have meter square, feet square. In volume, we have cubic meter, we have cubic feet. Okay, in velocity, we have in SI meter per seconds, feet per seconds in English system, right? And then we have in force, we have Newton. In SI, in English, we have pound force. In density, we have kilogram per cubic meter, pound per cubic meter. Specific weight, we have Newton per cubic meter, pound force per cubic feet. Pressure, we have kilopascal in here, pound force per square feet. But actually, this is the common is PSI, right? Pound per square inch. Okay, that's all for now. Thank you for watching. Please subscribe and do likes my videos. JBTeguihanon Engineering and Chemistry Tutorial. Bye for now.